Well, good evening, everybody. So tonight we're going to be taking a look at the brand new MidNite Solar inverter, which they're calling TheOne. So let's get started. So right off the bat, I did purchase this inverter with my own money. I wanted to take a look at this thing as soon as it became available. Really, with a lot of the things that I've read and seen, I was really getting excited about this new inverter that MidNite was putting out. We'll take a look at what came in the box, and then we'll look at some things about mounting it on the wall. Now this box is so big that it almost takes up my entire bench. I want to say this whole box is 4 foot tall. So it just means that this inverter inside is going to be pretty big. So let's open things up. Boy, I'm hoping I'm getting all this in frame. Almost. So first thing we see right on top is a template that we can use. Oh, it's got a sticky back on it so that we can lay this on top of our wireway and actually get our holes punched out. I like that it gives us the actual dimensions because this is one of those things that people are always asking me, what's the size of the holes on the bottom of the inverter? There we go. So on the left, we've got a bag of goodies. Quality control certificate with the serial number, a factory test report with all the results, everything that comes in the box, a quick install guide, and an installation guide. Oh, it must be a full user manual. I know one of these is like 60-some pages long. Yeah, that's this one here. And then the quick install guide. Okay. So that's nice. You've got your full user manual, but you can also just reference the quick install guide when you're trying to get everything configured and set up first. We've got a mounting plate, which I love the fact that these have mounting plates. It just makes things so much easier to install, especially when you're looking at near 100 pounds of inverter to hang on the wall. This might just be the hardwired dongle for internet. And then a waterproof grommet on the bottom. What do we have in here? All right, these look like they're, I forget what they're called. They're like conduit sleeves so that you can put these in your cutouts just to protect your wires and your cables from the sharp edges. Looks like you've got some for each hole on the bottom of the inverter. I believe these are called toroids. So the bigger one is for your battery cables. You'll run your battery cables through, and then the smaller one is for your ground wire. I believe these are for getting rid of electromagnetic interference on your lines. That's kind of cool. Here we got some lag bolts. I'm assuming these are for our bracket. They look like 2-inch lag bolts. And the goodies keep on coming. Our CT cables. It's kind of nice that it all goes down into a single Cat5 cable though. So you've got one pair coming off of here, one pair coming off of here into a single Cat5 that you only need to plug in one cable. No worrying about getting cables backwards or any of that stuff. Ooh. Oh, dropping stuff. This is packaged very, very well. I actually had some damage on the back of the box here, but there's so much air gap around the inverter and the ends are encased in the foam that there's no problems at all. cardboard dividers. Oof. Look at that. This is big. Let's get it out of the box. So I've got my template set on top of the wire trough. You really need at least a 10-inch wire trough, maybe a 12-inch wire trough for this to fit perfectly. I have an 8x8, so it's going to end up overhanging over the front a little bit, but that's okay. I'm going to punch out these back 3 holes and then set it right on top, but I don't want to peel the stick. I don't want to peel the sticker off the back. So I folded this along the line where it marked as the wall, and then I just taped it down, took a nail right into the center of each of the holes, and smacked with a hammer and marked right where the center of each hole is. And then what I'm going to do, I'll take my step bit and drill starter holes for each of these, and then a tool that I've come to love using when I have to punch into this metal is my hydraulic punch tool. It just makes things so much cleaner and easier. I've done it with the step bit the whole way, and it throws slag everywhere. So if I can minimize how much I have to use that step bit for, I drill a hole for the small knockout punch pin, and then punch that to, it's like 1/2 inch or 3/4 inch. And then from there, I can switch over to the larger punch pin and do the larger diameter holes. And it's so much better, so much easier. So let me drill the starter holes in these first. I'll show you how I punch these out, and then should be able to mount this thing pretty quick. Safety first. So there's for the first one. See all those little shavings? It's like hot metal flying out, whacking you. Something that I learned to pick up all these little shavings is I have one of these magnetic tool grabbers. But if you use this by itself, what it ends up doing is you can't get all the little shards off. So I'll put it on a piece of plastic bag and then just start going around to pick up all the little slag pieces. And then when it stops picking them up, I got a lot on here, I'll hold the tool over the trash can and then just pull the magnet away from the plastic. And then it all drops into the trash can. And I don't have the little pieces on the end of the magnet. So looking at our diagram, we can do 1.25 or 2 inch, 2 inch, 1.25 inch, and then another 2 inch over here. So I think I'm going to start with 1.25 over here. If I need to make it larger, I can. But we've got our initial holes drilled. I'll probably have to pop this cap off here too. But our initial hole will fit the smaller pin on our punch. So what we'll do, we'll take the pin, thread it into the cylinder. This is a spacer. We'll add that. Then we'll add our 1/2 inch on to that side, and our threaded side with the teeth will go underneath the wireway and thread on here. So we'll push this down through the hole. And then we just start pumping. And this cylinder will draw that die up and give you a perfect circle every time. And that gives us the initial hole for using the larger punch rod. So that'll fit in there. And then we can use the larger, or 1.25 and 2 inch dies to make this hole even bigger. So it's just rinse and repeat until you're all done. So according to the manual, from the bottom of the inverter to the bottom of the first bolt for the mounting plate is 29.97 inches. So I had my template on here, and I had marked the lines from the template on my wall, so I knew exactly where my bolts were going to end up lining up. And I've got my laser level here. I'm just trying to turn that and get that right in line with that line. And this is on page 3 of the Quick Start Guide 24.97. Just had to make sure. And since I have one, really I can just mount the one and then turn it, level it out, and then do the top bolts just based on where the bolts fall. So I grabbed a drill bit for my impact driver. I think it's an 1/8 inch. So I'll drill some pilot holes for our bolts that come with the inverter. And then I grabbed a socket to put the bolt in, and it was a number 10. All right, so one last piece of important information is remember to remove the sticker from the bottom of the inverter before you go and actually set it on your wireway. And you need to knock out your holes and use your bushing rings as needed. Peel the sticker off the bottom, and then I'm using the bottom 3. And it's very top heavy.
Mm-hmm.
I am off.
Yep, you're too,
I'm too low.
Yep.
By a lot.
By like an inch.
How in the world am I that low? Yeah, how'd that end up being a...
Half inch?
Yeah, 1/2 inch. That stinks. What? It's not going anywhere. Let's stand it up like we did before.
I was thinking the same thing, like that.
That's a whole lot easier.
Nicely. I gotta go your way.
My way. I'm on the bracket.
No.
How are you not?
There we go.
Looks pretty good. Pretty close. I probably bent the I probably bent the wire away a little bit. Now the question is, do my holes line up?
Wow.
They're not that bad.
You're really good.
For not sticking the sticker down, that's not too bad. Now the question is, will my, whatever they call these things, gasket, grommet, thingies, glands, what do they say? Knock up, bushing rings. I'll get it eventually, bushing rings. Do my bushing rings fit? No. They're pretty close. So I want to go over some of the specs of this inverter. I'm sure if you knew anything about this inverter, you've gone through the specs multiple times, but for those of you that aren't familiar with this, I'll go through them real fast. So spec-wise, width on this inverter, 16.5 inches to the outside edge. It does flare out a little bit. It might actually be the exact width of the brackets in the back. Depth from the wall is a little over 10 inches, like 10 1/8 maybe. And then total height is 37.25 inches. And I want to say this thing weighs around 100 pounds. So starting at the top of the inverter, it's got some indicator lights. We come down to the display, which is 2.5 by 2, and then we come down to the wiring compartment, which is about half the size of this inverter. On the left-hand side of the inverter, we have a spring-loaded handle to easily help mount this onto the wall. We have a PV disconnect, latches to get into the lower compartment, and then an on-off button. On the right-hand side of the inverter, we've got some warning stickers. This little thing just caught my eye. It says, scan to download your app for PV. More surprises are yet to come. We've got our spec sticker, and then down at the bottom is our Wi-Fi and LAN connection port. And one thing that I'll point out is that's really nice is these brackets, the mounting holes do actually stick out past the back of the inverter. So you can actually tighten everything down once you get the inverter mounted onto the bracket. And something that's different from other inverters that I see, most of the other larger inverters have fans that suck air from the side and they suck air across the unit. This inverter has fans on the bottom and then it sucks air up and discharges it out the top. And so I mentioned that this wiring compartment takes up about half of the space. So you're looking at almost 20 inches of the wiring compartment where the upper section is a little under 18. So if we pop the latches on the side, we can take a peek at the inside. And so with this faceplate on, it looks pretty simplistic. But up in the top left-hand corner, we have a DC rated breaker for 300 amps. And then a lot of inverters have started adding in breakers into their wiring compartments because breakers are things that you really don't think about when you go to buy your system, and you need to add those in for disconnects, for safety reasons. And they went through and added a bunch of their breakers because MidNite makes some great breakers. I want to say they're like, are they magnetic hydraulic breakers? But they added in all their own breakers into this system. Normally, if a system adds breakers, they'll have a battery disconnect, an AC output, and an AC input. Well, they added a whole lot more so that you might not even have to add a sub panel. You could actually wire everything into just these breakers here. Or if you need to feed to another location, another building, you can use the AC out for that and then use these for local power that you need around the inverter itself. So we've got 4 load breakers here. 3 are 15 amp load breakers and 1 is a 20 amp load breaker. These white breakers in the middle are different. They're double pole, but these breakers are smart load breakers. And what I mean by that is they actually can be controlled as to when they turn on and off based on state of charge. And I believe there actually might be some other features that will let you control when they turn on as well. I haven't dug into everything to see. Not only are these smart load breakers, but they are also input or output breakers. At least 2 of the 3 are. So on the left-hand side, we have a double 60, which can be used for your generator input, or it can be a 60 amp output. That could be EV charger. The middle one is a 30 amp breaker, double pole, which is output only. That one could be, I don't know, your water heater. And then your last set is a 50 amp double pole breaker, which can be used for your AC coupling input or a 50 amp output, like your electric dryer. And then you've got a double pole 100 amp AC output breaker and a double pole 100 amp AC input breaker. And if we open up the lid to take a peek at the inside, and I know I forgot to mention it earlier, but this is a 120/240 split phase inverter. There's always these little things that I tend to forget when I'm going over all this stuff. It's a 10,000 watt nominal output, but you can output up to 11,400 watts with PV connected as well. The surge on this thing is, let's see here, 60 seconds, you can surge up to 14,000 VA. And 1 second, you can surge up to 15,000 VA. In fact, the leg imbalance on this is supposed to be crazy strong. I think I actually just saw a short from Current Connected where they had 60-some amps on one leg, when the maximum current on one leg is 47.5 amps. So you've got your double pole, or your 300 amp DC rated breaker, and then you've got your terminal connections for your battery positive and battery negative. Moving over, all of these breakers are on a DIN rail, so they can actually be easily removed and swapped out. And actually, that's a great segue that this entire inverter, I believe, is supposed to be field serviceable. And when I say field serviceable, that means that if you have a problem with this inverter, you should not have to take the whole thing off the wall, box it up, and send it back. You should be able to get the part you needed to fix whatever's going on, and then replace that part only. I don't think any other inverter has that ability. Every other inverter that I've heard is, well, send it back. We'll take a look. That could be weeks But this thing, nope, we'll send you the part. So I can't see a gauge on these first lines, but I'm guessing probably 12 gauge on these wires. And these are all silicon wires. Let's see here. We've got 8 gauge on the 60 amp breaker, 10 gauge right here. I don't know if you can see it. It's upside down, but 10 gauge for the 30 amp, and then another set of 8 gauge for the 50 amp right here. And then looking at our 100 amp, it almost looks like right here above this label, AC grid line 1, I believe this is starting to say 4 gauge. Right here, we've got 105 degrees Celsius temperature rating. These are silicone wires again, so probably 4 gauge on these. With these 100 amp breakers, this does have the ability to do a 100 amp pass through. This is a hybrid inverter which allows you to sell back power through the AC input back to the grid, assuming you have things configured properly with your utility. These smart load breakers I mentioned a minute ago, AC coupling, you can AC couple on this breaker up to 10,000 watts coming in to the inverter. Working our way down, we've got our neutral bar here, our ground bar right here. Down here is our PV connection points, which these are stiff spring-loaded latch connections for PV. The first 2 sets are for PV1, the next 2 sets are PV2, and the third 2 sets are PV3. So you can actually bring in 2 strings and have the inverter do the paralleling at the inverter for strings 1, 2, and 3. So you don't need an external combiner box. Now, PV specs. So overall, this can handle up to 15,000 watts of PV. I want to say you can actually connect, I think I was told double that. I mean, it's a waste of power, but I think you can connect up to double. Each string can handle up to 600 volts PV with a voltage range of 70 volts to 550 volts. And the startup voltage for these is actually pretty low at 90 volts. Most I see are 100, 125 is the startup. I mean, Victrons are lower, but a lot of the other ones I see are at least over 100. So this is nice to have a lower startup voltage. That means that you can get a little more power at the beginning of the day and a little more at the end of the day. These PV1 can handle up to a maximum of 30 amps of current, and then PV2 and 3 can handle up to 22 amps paralleled. So you could do 2 strings of 15 to get up to 30 amps. It's designed to allow you, because you get these panels nowadays that the current rating is higher than, 12 amps, 13 amps. So you can't parallel anything together. But this will allow you to do parallel strings because it can accept higher current rating on PV. So that's going to be huge, because I know in my case, I think my panels are 11, 12 amps apiece, and I can't parallel them without losing power on my other inverters because they'd be clipping because they'd be too high, but not on here. So again, 30 amps for PV1, 22 amps for PV2 and 3. And then moving over to this last section, we have a battery temperature sensor jack. Up here, we have a RSD remote shutdown terminal block. So these 2 wires here for your remote shutdown switch. 3 and 4 are, I believe, for an external switch. I could be wrong. Along the bottom, dry contacts for generator start, stop, and I'm sure there's a bunch of other things that you can use that for. Port for your CT clamps, BMS, RS-485. I think this means that you can have external RS-485. Maybe even read the RS-485. I don't know, but that's a separate RS-485 port. And then up here, this is for paralleling the inverters together. And with this inverter, you can stack up to 9 of these in parallel together. So 90 kilowatts of output, which is just crazy. I mentioned the remote shutdown a minute ago. It does have a built-in AP Smart remote shutdown transmitter built into the inverter itself. It's this gray box right back here. So I do want to take a peek behind the upper section of the inverter. You've got 3 screws down here along the bottom, and then around the corner on the back, there's 3 on this side and 3 on this side. And if we take the lid off, we've got 2 ribbon cables right here for the 2 different displays. Just disconnect that one and disconnect that one. So in seeing everything in here, this does remind me this is a high frequency inverter, not a low frequency inverter. So let's see if we can kind of figure out what's going on here. I do see everything has the conformal coating on the boards. So our PV lines come up from a bundle down here into the disconnect switch and then up to this board up here, and then it goes up here through more toroids, it looks like, and then it goes back to probably the inverter board, which is probably this board in the back, I'm assuming. Looks like a common PV negative line, an 8 gauge PV negative line. I'm guessing these PV positives are, oh yep, there it is. You probably can't see it, but it says 12 gauge right there. Large bank of capacitors, bunch of relays. You see quality control marks all over the place. This is kind of neat. You've got your labels on your wires, and then if you can see behind it on the board, it shows you LB and then LB right here. So that's great to see. So that way, if you do have to service this and you disconnect it, say you have to replace a board, you know exactly where your wires are supposed to go. So similar to the last inverter I looked at, there's only one fan inside, and that's this one right here, and it seems like it's just to circulate air around in the compartment. All the cooling is done by the massive heat sink on the back. As I look at the build quality of this board, I'm reminded that some of the folks that work at MidNite Solar right now also used to work at Xantrax and Trace. I believe they worked on the Outback inverters. There's another one that I can't remember right now, but either way, I see the quality in this inverter and I kind of expect it, knowing that they also worked on those other inverters that have just worked for years and years. I mean, I know folks that are still using Trace and Xantrax inverters. They just work. And so I'm looking forward to seeing if this inverter meets the same longevity and quality standards as some of those other inverters. This inverter does come with a 10-year warranty. Again, I said it's field serviceable so that if different components fail for whatever reason, you can have those components replaced and not just have to take the whole inverter down and send it back. It's got a lot of certifications and built-in safety features. I want to read these because I always get these wrong. Now, electronics certified safety by SGS Labs to NEC and UL specs. Grid sellback UL 1741 from 2021. IEEE 1547A from 2018 and 2020. FCC 15 Class B. UL 1741 SB, and CA rule. Hawaiian Electric Company's IEEE 1547.1-2020, effective on July 1st, 2020. We've got the PV disconnect switch, ground fault detection, PV rapid shutdown control, arc fault detection, PV input lightning protection. I have to look at that. That's cool. I didn't know about that. Reverse polarity protection, the 300 amp battery breaker, and then surge protection for DC Type 2 and AC Type 2. This has a lot of stuff packed into one unit. I was reading the forums last night, and somebody was saying that the MidNite breakers alone in this inverter are at least costing you anywhere from, I think somebody said $600, and then somebody said like $1,000, just from all the different MidNite breakers that they're including in this inverter. I'm excited. I can't wait to get this thing wired up and get it fired up, because I want to see how it's going to perform. I want to see, for myself, how's the surge, how's the load, How's the leg imbalance? What's the idle consumption? Early on, they said 60 watts. The manual now says 85 watts. So I'm guessing it's going to be somewhere in between that 60 to 85 watts. So we'll see what that is. It looks slick. So far, the only thing that I don't care for on this inverter would be the fact that when I'm hanging it or when I touch the white, it leaves, you can see your black fingerprints and stuff on it. So it's gotta stay clean. It's gotta be nice. But that's so far, I mean, granted, I've just got this thing on the wall and looked at it. I haven't fired it up yet, but it's the only thing that I can say right now. So hopefully I've piqued your interest. If you want to follow along and see how the MidNite Solar 1 inverter does, I'll leave links in the description below to Current Connected, to the discussion forum where they've been talking about the MidNite Solar inverter. So come along with me as we try and put this thing through its paces, see how well it does. But I'm excited. So with that, I'm gonna let y'all go. Y'all stay safe, stay cool, and we'll catch up with you later.